Yo, welcome back. We're on day number 16. Yeah, day number 16, and we are going to be solving the question same binary tree. So, we're gonna have a quick go, read the question, see how we do, and yeah. Okay, so given the roots of two binary trees P and Q, return true if the trees are equivalent, otherwise return false. Two trees are considered equivalent if they share the exact same structure and the nodes if they have the same values. For example, input 1, 2, 3, Q 1, 2, 3, true. So that means that the same, and then 4, 7, 4, 7, false, and then 1, 2, 3, 1, 3, 2, false. Anyway, my dog bit me, so little fun fact. But yeah, cool. So basically, we're gonna be comparing the trees, and if they don't match, then we're gonna say that it's not a match. So I think that it's going to be a breadth first search because you want to go like this. Want to move bow, and then check those two if they match. Yeah, BFS is probably the best one to do over here because that first search back, it's okay, but we want to check one by one, and then we don't want to proceed until we've done so. So let's get started. So first things first, we want to check the nodes are. So if they're no. So if they're no, we'll just say that they're return true because they pass. Otherwise, let's make a static VFS underscore identical, taking two parameters, same as that, P and tree node Q. Okay, so first, check if our trees are empty. So I guess we just do pretty much same line as here. Yep. Right, and then we wanna, so if it passes this check, for BFS we work with queues, so create the objects. So it's literally gonna be like Q1, I guess Q1 is going to be Q. How the hell do you define these objects again? Oh, let's see how you define these objects. No. Just want to see how we define it. Q. Why, isn't it just like Q? I mean, something like this. But then, how would you? So, one second, guys. Okay, so we'll put Q and we'll put a node of the Q. Okay. So Q tree node. Because it's just harder to do it in this environment than rather than IDE. Because you just kind of get like the color code and response. Okay, Q1 equals new Q tree node, and let's copy that. Cool, so then to find the object, now we loop through to begin our BFS. So it's gonna be quite important that we do something like this. It's greater than 0. So if both of, so basically, if that condition fails, it can't be identical because they both need to be greater than 0. Like it can't, one cannot be 0 and the other one be 1 to start off with. Just instant fail. Just bear that in mind. Okay, cool. So we loop through it. So we enqueued it. So do we enqueue it or do we dequeue it? I don't know. Okay, so mishap for point. So we need to populate our queues with the values of the trees. So literally just gonna be q.2.enqueue. Well, I guess it's gonna be like enqueue. It's gonna be p. Q. Right. Cool. So in comparison to need to dequeue the elements. So we would do like this. We would do something like, let's say, hold on a second. If we did that, how would that go? Alright, cool. But would that work? Yeah, we don't have to pass anything in. Right, cool. So we dequeued both the elements. Now, what do? We compare it first. Compare the data first. See everything is identical. So if Q1, no, but if it's identical, we just do q.data because, well, q.val, let's just say q.val. So if p dot val is not equal to q dot val, straight away we can see false. Okay, so if that check passes, check the left child. So if p dot left no and is not equal to q dot left, I'm going to do a no check. Then we are saying return false. Okay. And then, so if the check is passed, we can move on and we can enqueue the element. So let's just, like, you can just do it for p left equals no. And then it's gonna be q1 dot enqueue p dot left. Yeah, cool. Check the right child. So it's literally just going to be the same as this. But just for right. My Vim is like not that good yet, so do not judge me. I'm joking. It's come across harsh. In my YouTube video, got keyboard professional outlook. Yeah. Right. See that critical thinking, because I know there's a T in right, and I know there's a T in left, so I only removed 3 letters instead of 4, so I saved myself, and the time complexity is an O of 1, and now the RAM usage is 7 instead of 8, so I'm, yeah, cool. Nah. Right, so Q. Right. Okay, so this is the while loop. So now we check both counts are 0, so we can say that is identical. There's only one thing I'm scared of, like, do I have to do this? Do you know what? Like, I'm gonna just do it because low-key, I think you have to do that. Yeah, let's just do Q dot right and just Q. So if Q1.count is equal to 0 and Q2.count is equal to 0, then we say return true. Else, if this is not true, then we say return false. Right. Call our method now. Is it the same tree? So BFS underscore identical and we just pass in PQ. See if it passes. What would I do wrong? No code path return a variable. I think that one, there are some errors in logic. So these should all be not. I don't know why I did that. Because I would just have issues. And this is just a simple return statement. Because we want to return the variable, the method result. And let's just see what it's saying. So I didn't pass the first test case, but I passed the second and I passed the third. So is that saying that if it's identical, because this is identical, why did I go false? What the hell? What the hell are you up? there is a logic error where this should actually be left instead of right. I don't know why I did that, was quite silly. What other kind of film? What? Or how did this? Interesting. What can I do? What can I do? If we're doing these, we don't need to double check it here. Okay. Q's is fine. It's fine. It's fine. It's fine. Oh my god. Oh my god. I only include. Oh, that's why. Cause I only include. I need to include both of them. So silly. Okay, let's see how this does. Colon. Okay, what is wrong now? So I have to change this to false. And then hopefully that passes. Let's do this one first, because logic. Wow. Wow. That was difficult. Okay, see you guys in 10 or 17. Bye bye.